Hello class, I'm going to go over a few of the problems of your math homework. I'm going to only go over the ones that are highlighted. So for number 5 over here, we have f of x equals 25 x cubed minus x6 plus 33x minus 12. Alright, so just to refresh your memory on taking the derivative, we have 25, you take the exponent, which is 3, multiply that, times x, then you do 3 minus 1. In the next one, we have a constant of 1 out front. The exponent is 6, so multiply that out front, times x to the 6, you subtract 1, and then we have plus 33, and the exponent is 1, so multiply that by 1, and you do x, and the exponent is 1 minus 1. And the last one, we're in another room here, is minus 12. And if there were an x here, it would be x to the 0. So we would multiply this out front by 0. X to the 0 minus 1. So we can simplify this to 75 x squared minus 6 x to the 5th plus 33, and then minus 0. That was a little refresher. Now for number 6, here is a little bit trickier because we have, take the derivative of 1 over x to the 5th. Much easier if you simplify it to x to the negative 5th and do the same process. So our constant out front is 1. We have, bring down the exponent, so it's negative 5 times x to the negative 5th, and you subtract 1 minus 1. And you should get an answer of negative 5 x to the negative 6. Or you can rewrite it with the exponent down, or the x in the bottom. Now over for number 10, over here, so now we have to take the integral, which is like the opposite of a derivative. So here we have the integral of x to the 4th plus 23 dx. So now, to do the opposite, we're going to tackle our exponent first. We're going to add 1, and then we take that number, our constant out front is 1 here, and we're going to divide by this new exponent, which is 5. And now we have another number, plus 23. Our exponent was 0, but now we're going to add 1. We take our new exponent, which is 1, and we divide that by 1. So if we were to simplify it, we would get 1/5 x to the 5th plus 23x. Now don't forget to add c, because when we take the derivative, the constant goes to 0. And when we take the integral, which is going backwards, the opposite of derivative, we don't know if there's a constant or they are present. Because taking the derivative of this, the constant would go to 0. So we add that just in case, and if you're given initial conditions, you can solve for that constant. Number 11, a little bit trickier because we have a fraction. Alright, it's much easier if you were to simplify the fraction to x to the minus 2 dx, and do the same process. So x to the minus 2 plus 1, we have a constant 1 out front, and then we're going to divide by our new number, which is minus 1. So divide by minus 1, and now our answer should be negative 1 over x, and then plus c. Alright, for number 12, scroll this down a little bit. Now we have an integral with limits. Okay, so make sure you take the integral correctly. So our limit is 2 to the 4th. We have 2x cubed plus 3x minus 24 dx. Okay. So we have x, add 1, which is 4, and you do 2, divide by 4, plus we have 3x, add 1, which is 2, divide by 2, minus 24 x, and our limits is from 2 to 4. All we do is plug in the 4 into x for our first part. I'm going to reduce this to 1/2. So we have 4 to the 4th plus 3/2 times 2 squared minus, oops, did I do that wrong? I did do that wrong. It's not 2, it's a 4. Square minus 24 times 4. And then subtract minus, now you have 1/2. Now we're going to plug in the 2 times 2 to the 4th plus 3/2 times 2 squared minus, see if we can fit this in here, 24, nope, I'm going to put that down one line, minus 24 times 2. Now it's just pure calculations. And I got 90 for my answer. For 13, the trick here is to know how to reduce the original equation. So here we're given x to the 4th minus 21 x to the 5th plus 10 all over x to the 4th dx. If you simplify this equation, it actually becomes a lot easier. So we're going to cancel the 4's up here, so that becomes 1. And the 4 with this number, this becomes minus 21x. And then x to the 10 is 10 over x to the 4, but I'm just going to put the x up top and do minus 4 instead. Now the integration looks a lot easier. So we have a constant, so that's just x. Oh yeah, and our limit's from 1 to 3. We have minus 21x, this is going to add 1, so it's squared, divided by 2. And then here, I know it's going to be a minus, so I'm going to put that up there already. 10x, add 1, so it's minus 3, divide by 3. See, I already substituted that minus there because I knew that was going to happen. And then our limits from 3 to 1. And then you just do the same substitution again. Plug in 3 into here, then plug in 1 over here, do some calculations, and I got negative 79. For 14, we want to find an equation of the line tangent to this function here. Okay. If you have a function and you want to find the tangent to this function, or even to a point, you take the derivative. Plus 3. So we're going to take the derivative of this function, dy dx, and this actually is equivalent to the slope. So we have 3x squared minus 10x to the 4th, and then a constant is 0. And this equals the slope. And we want to find an equation at a certain point. So this point is at 2 comma negative 53. So the x is 2, so we can plug that in. So 3 times 2 square minus 10 square to the 4th, which gives us our answer to the slope, which I got, where is it, negative 148 for our slope. Now the goal is to find an equation of the tangent line. So a tangent line is a straight line. Alright, this is some function. Alright, we have a point at 2, negative 53. So wherever that is, we'll pretend that's there. And then we want to draw a line tangent to that point. Okay, we just found the slope, which is a negative, so I guess technically it's going the other way. But we have a negative slope, and since it's a straight line, we know the equation for a straight line, which is y equals mx plus b. We know what m is, so we have y equals negative 148 plus b, oops, times x. And the only thing we have to do is solve for b. which you can do. Make a substitution with our given points here. So I substituted in 53 and 2, and I solve for b to get negative 373. And now I have my full equation, which is y equals negative 148x minus 373. So that is the line equation that is tangent to this point of interest. Alright, last problem. Now we want to find if any points along this function have horizontal tangents. So here's our new function, minus 4x squared plus 6. So when we have our function, if this were graphed, who knows what it looks like? There we go. Any points, slopes that are 0, horizontal tangents, right, would look like that. So those are all the points that I see in my makeup graph that are horizontal tangents. And the slope for this here is 0. So when we take the derivative, we find the slope. So the derivative of this function is 6x to the 5th minus 4 divided by 2 is 2x, and then that becomes 0. So this is our slope function here. Now our slope has to equal 0 to find the correct points. So we have 6 fifth minus 2x equals 0. You notice one of the x cancels out, so one of the x's can be 0. If x equals 0, this equation is true. So there's one point in the x point. Now, let's simplify this. So we have x to the 4th minus 2 equals 0. So another value that x could be is you solve for x, and we get x equals plus or minus, where is it? 1.07. The reason why I put this plus or minus there, because when you take the square root, you have to do plus or minus when you do the square root function. I forgot to put plus or minus right here. So it could be negative or positive. So that's 3 values for x. To find y, you plug x back into the original function to find the y points. So we get our points of coordinates. So we can figure out where this point is, where that point is, and so on. So we have 3 points in this example here. So I plugged in x into here. The first one's quite obvious. It's 0, 6. All right. Another one, all right, 1.07. Whether it's plus or minus, it doesn't matter, because since it's an even exponent, the minus just becomes positive. So we actually just have 1 point, and when you plug that in, you get 2.92. So here are our 2 points of where there is a horizontal slope, or horizontal tangent line, where slope equals 0.